My name is Cody Hartsook. I'm a software engineer.
I am Aditi Gupta. I'm a software engineer as well.
So today we're going to go over a little bit about agency. I'm sure you all have heard it before. And then we're going to touch on what is coffeeAGNTCY, what is application SDK, and how does it fit into the ecosystem of agency, and a little bit about where the vision of where we think these are going to go.
To start off, agency is an open source collective that is focused on building out the Internet of Agents. And the Internet of Agents is supposed to be a diverse, collaborative space where we can have multiple people come together and talk about how we want to build the foundation of this new Internet.
So just to jog your memory a little bit, we have these key pillars within agency that we're looking at that we think will be crucial in the development of the Internet of Agents. So some of these are agent identity. How do we know who we're talking to when we're talking to an agent? Directory, storing these agents. How do I discover agents? Semantics, what is the language that agents talk to each other with? Transport around, what are the different messaging protocols that we need? And then observability and security, what's happening within our agents and across agents.
And in order to exemplify how these different components are going to come together, we've built out a reference application called coffeeAGNTCY. So coffeeAGNTCY is a fictitious coffee company meant to show off a real world supply chain example and show how we can build out a multi-agentic system in order to kind of show the end-to-end of leveraging agency components. With coffeeAGNTCY, you can leverage the App SDK factory, explore Slim, check out NATS, see how easy it is to switch between different agency components and write out a few agents along the way. So within coffeeAGNTCY, we have two different demo applications. We've got Corto and Lungo. Corto is our simple, minimal demo application. It's meant to be a very accessible entry point, but the meat of our work is in Lungo, and that's our ever-evolving demo application where we show off many of the different agency components. And within Lungo, we look at two different examples of supply chain use cases. We've got the auction example where you're looking at inventory and orders. And you also have the logistics example where you're going through how a buyer, a shipper, an accountant could work together with a coffee farm. So we're going to go ahead and do a live demo of this because we're feeling gutsy today. And across these different demo examples, you'll see that we're looking at different agentic patterns. So our first one is focused on PubSub, and we're using NATS as our transport. The point of this is to show how you can have kind of a supervisor agent talking to different worker agents in a publish and subscribe way, right? So in our example, if I go ahead and let's say I want to get the yield from these farms, what is happening in the background here is our buyer agent is actually publishing to a shared topic on NATS and asking for farm yield. Now, each of these different farms are subscribed to that same topic, and they're going to go ahead and reply back on that same topic with their yield. We actually have one of our farms, the Columbia farm, talking to an MCP server in order to get real life weather updates. So not only is it an A2A server, but it's also an MCP client. And so all of our different agents are actually lane graph orchestrated A2A agents. And so we're showing how you can use A2A across NATS with PubSub. So another pattern that we're showing off is secure group communication, and I'll pass it on to Cody to talk more about that.
Sure. So in the first example, a little more about hierarchy, supervisors, publishing down to multiple recipients. Just one benefit too of something like that. How does that translate to the agent level or lane graph level part of the application? Instead of doing n sequential tool calls, we can tell the agent, you just have to make one tool call. And not only is that, less network calls, but it's, more simple for the agent to reason about. It's one tool call as opposed to a sequence of them. In this case, instead of having this hierarchy of a supervisor publishing out to a set of recipients, we're going to have a secure group that members are invited into. So we have a logistics agent, and I can ask a question, can you order a certain amount of coffee? And then we're going to see all of these agents collaborate and share messages to give updates on what the status of that order is. So we have a shipper, we have accountant, and then we have our Tatooine farm. And what's going on in the background is we are using the Slim protocol to create this secure moderated group chat in which everyone is hearing these broadcasted messages. So they're all going to be collaborating, broadcasting to each other. Should be seeing kind of logs and messages come in. It's very collaborative, very open. Again, there's no hierarchy here. And then once one of the agents completes the task and signals, I was the last person that needed to work on this, I could signal that my task is complete. And then we can essentially broadcast an end message saying, our group chat task has been completed and we can all leave, and we can all go home. All right, so how did we actually do this? So we're leveraging another project of ours called Application SDK, Agency App SDK. And part of this is trying to create these abstract notions of those different pillars that we had. So we have identity, we have messaging, different agent protocols, observability. So we're trying to create abstract versions of these and then create a factory that can essentially allow you to retrieve any concrete type that you have implemented. So for instance, for agent messaging, we have Slim. And again, we showed Slim for this group chat, but we also have NATS and we also have Kafka. And we would like to be able to show different communication patterns with different messaging types. And then we also have different protocols, 808, FTP. If you scroll just down a little bit further, you can see how we want to use this abstract notion and this factory class. So I can essentially ask the factory, I would like to create a transport of a certain type. That transport type, again, could be something like Slim, so that's something like NATS and like Kafka, and then serve this agent on that transport, given, let's say, a topic. Then on the client side, let's say the supervisor, I can now say, I would like a client of this type. We're asking for 808 here. We're going to pass in a transport. So again, it could be, let's say, Slim. And then we're going to just send a message given our clients and given that transport. So we think this pattern will allow us to try out different communication patterns and evolve these different pillars and hopefully create kind of robust, mature interfaces for the pillars that we are working on. So that is it for this introduction. All of our code is open source in the Linux Foundation. Please come and try. And
Thank you.